In this video we're going to find out more about binary trees and how you can traverse pre-created binary trees. Let's start off by discussing what they are. They basically utilise linked list attributes such as the data item and the pointer, and the operations that you can perform on linked lists in order to represent a collection of data in a tree structure. And the difference between a linked list node and a binary tree node is essentially that the binary tree node has two pointers. Because binary has two possible values, a binary tree node has a left pointer which goes one way and a right pointer which goes the other way. And these can be combined into a tree structure, as you're going to see on the next slide. So in this example binary tree, we're going to have a number of nodes. We have node A and B and C. So node A, as you can see, node B at the top here, is the parent node or the root node of the tree. And it has two child nodes, A and C. Now with A, because it has no child nodes attached to it, it is called a leaf node because it has two null pointers and therefore it's not connected to anything else. With C, we have one null pointer because there's no left child. However, it does have a right child, which is E. E has the reverse, it has no right child, however it has a child to the left, which is node D, and this is also a leaf node because it has no child nodes attached to it. The null pointers signify the end of the branch if you have both of them. If both left and right pointers are null, then you can say it's the end of a branch. With binary trees, there are three methods of traversal that you need to know about. There's in-order traversal, there's pre-order traversal, and there's post-order traversal. I'm going to play these three videos one at a time and just briefly describe how they work. So with in-order traversal, you start with the parent node. With all types of traversal, you start at the parent node or the root node, but with in-order traversal, you go to the left node first, and then when you've exhausted the left node, you display the parent or output the parent, and then you move on to the right node and you process the right node. So in-order traversal is essentially LPR. With regard to pre-order traversal, we start with the root node as before, but with pre-order traversal what you do is you start with the parent node, then you evaluate the left node, and when you've finished with the left node, you evaluate the right node. So this is known as PLR. And lastly, with post-order traversal, you start with the left node and you travel as far as you can on the left. You then deal with its sibling on the right, and when you've finished with the processing left and the right nodes, you display or output the parent. And this is known as post-order traversal, which is LRP. I'm now going to play these three videos and describe what happens in each of them. So with our in-order traversal, we start with the three nodes at the top of the tree. And as I said before, we always start with the root node. The robot here will show you where we're currently looking in the binary tree. So it starts off with B, but we don't display it. We go immediately to the left node, and when we go to the left node, this becomes the parent node, and the process starts again. First, the robot tries to go to the left, but there's no child node. It then goes to the parent and outputs A. And then finally it goes to the right and tries to evaluate the right node, but there's none. So we then move back up a level of the tree. We've processed L, so we then display node B as the parent and then evaluate the right. Node C becomes the parent, and we evaluate the left-hand side. We then output the parent and then go to the right-hand side. The right-hand side has a node, so it becomes the parent. We then evaluate the left-hand node, output the parent, and go to the right-hand node. Now I skipped a step here because what I should have done was move down to node D when it became the parent and output that, because the parent node would have been D at this point. Anyway, this in-order traversal outputs A, B, C, D, E in that order. With regard to pre-order traversal, we start with the 3 nodes at the top, but because we start with a parent, we output the parent first, so the first letter would be B. We then evaluate the left-hand node, and that becomes the parent. We output A as the parent, and then we try to evaluate the left node, there is none, and then the right node, there is none again, and then we finished evaluating those 3, so we can return back to its parent. We've evaluated the P and the L, so we look at C as the right node, and it becomes the parent. We output C, and then we evaluate left and right. There is a right-hand node, so it becomes the parent. And then we move to D, it becomes the parent, and we'll output D as the node, and then go left and right, and then back to E and evaluating right. And so the output from this pre-order traversal is B, A, C, E, D. Lastly, let's look at post-order traversal. Now with post-order traversal, the root node is the last thing that should be output. So let's start at the top with BAC. We start by looking at the left-hand node, which then becomes the parent. We then try to look for the left-hand node, there's none. We look for the right-hand node, there's none again. And then we evaluate the parent and output it. So we output A. We then go to the right-hand node for its parent and evaluate that. So C becomes the parent. We try and evaluate left, there's no node on the left. We try and evaluate right, there is a node on the left, and so it becomes the parent. We go left, and there is a node, D, which then becomes the parent. We try and evaluate its children, go left and right, and output D. And then we go back to E, we evaluate the right-hand side, there's no node there, so we output E. And then we output C as we move back up the tree, and last but not least, we output the letter B as the final letter in our traversal. So we end up with A, D, E, C, B as our output. And so now you can see there's 3 methods of traversal that you need to know about, and they all give different combinations of nodes depending on the method of traversal that we've selected. I hope this makes sense.